part 2 of 4.1. We're going to get into local extrema. So we're going to look at where a local maximum and a local minimum can occur. So a local maximum is when the function goes from rising to falling. And a local minimum is where it goes from falling to rising. So looking at a graph, and we have a critical value. We look at the point and see where is it going from rising to falling or falling to rising. So if we look at this first critical value, my graph is still declining, still falling. So that is neither. But our critical value number 2, you can see it's coming from falling to rising. So this is a local min. Critical value 3 is going from rising to falling. So this is a local max. Critical value 4, it's falling and then it's rising. So this is a local min. Critical value 5, it's still continuing to rise. So this is neither. Critical value 6 is a local max. And 7 is neither. So we're going to look at this graph, and you're going to determine the intervals of where it's increasing, those where it's decreasing, and then determine if you have any local max or min. Okay, so hopefully you were able to determine that from the graph. Okay, determining if our local extrema is a critical number. So case 1 is when our first derivative goes from decreasing to increasing, which we talked about already. And there's a graphical example. Case 2 is when, for a local maximum, is when it goes from increasing to decreasing. And there's a nice example. Case 3 is when it does not change sign at all. When it doesn't change sign at all, it's neither, which we saw from our original graph that we were looking at. There's an example. This continues to increase. When it doesn't change sign at all and it's all decreasing, again, it's neither. There's an example. When the derivative equals 0, Okay, we have a horizontal tangent. It's a local min. When it changes to positive to negative, it's a local max. When we have horizontal tangents that are neither, okay, there's an example where it's negative on both sides, where it's positive on both sides. When we have an undefined tangent, such that it creates a V, okay, it's negative on one side, it's positive on the other side. Be not defined means that we would have a vertical. Okay, so that's a local min, a local max. Points that are neither maximums nor minimums, okay, is when we have our first derivative is not defined, but our original function is defined. Okay, so that's where it's kind of doing that changing concavity, which we'll see in our next section. All right, so let's do an example. We're going to find critical numbers and find the local maxes and mins. Okay, so the first thing you need to do is take the derivative. Set it equal to 0. And our two numbers are 1 and 3. Okay, so we create a sign chart, finding out what's the sign at each of these. So when it's less than 1, it's positive. When it's between 1 and 3, so say 2, it'll be negative. When it's greater than 3, it's positive. So it's increasing here, decreasing, increasing. The local max and local min, this would be a increasing to decreasing a local max. And this would be a local min. To sketch a graph, so let's look at what we have here. So from negative infinity to 1, it's increasing. F at 1, so local max. From 1 to 3 is decreasing. F at 3, which we're going to figure out what that is. So local min. And from 3 to infinity, it's increasing. So we need to find some points. So I'm going to go back up to my original. F at 1 is going to be 1 minus 6 is negative 5, plus 9 is 4, so this is going to be at 5. At 3, the original function is going to be 27 minus 54 plus 27 I get it at 1. So let's graph that. Put a 0 in there, we get 1. So it's going to start here. Then at 1, it's 5. At 3, it's 1. So it's increasing, decreasing, increasing. Local max, local min. Okay, you go ahead and try the matched problem. Okay, so some applications, even though I didn't give you applications in our assignment, I want to at least go over them so you have an idea what to expect going forward. So we're looking at this graph. It's a graph of the first derivative. Okay, so determine when the prices of eggs are rising and falling. So think of this as a graph of our sign chart. Okay, so it's negative, positive, negative, where this would be a local min. This would be a local max. Okay, it's falling on this interval from 0 to 10. 10 to 50, it's rising. And from 50 to, I think the last number, 70, it's falling. So a sketch of that might look like 10, 20, 30, 40, 50, 60, 70. At 10, it needs to be a min. And at 50, it needs to be a max. So it might look like that. All right, so you go ahead and do match problem number 8, and I'll have some questions for you. Okay, this concludes